Hello, I am Ehsan Intezari. I am corresponding author of paper as on the assessment of non-metallic inclusions by Part 13 of API 5791 ASME Fitness for Service 1 2016. I am from National Polytechnic Institute, Mexico. The non-metallic inclusion zones are considered as laminations for assessment purpose by structural integrity engineers through Part 13 of API standard. This study follows two main goals. The first goal is level 1 and level 2 assessment of pressure vessel containing non-metallic inclusion zones by Part 13 of API standard, and goal 2 is adopt the conservative fitness for service assistant procedure and criteria presented in Part 13 of API standard. Here in this slide, you can see the assisted pressure vessel containing non-metallic inclusion zones. This pressure vessel has been installed and operated in oil production offshore facility, and the figure 2 shows a pressure vessel design drawing. We found non-metallic inclusions by phase array ultrasonic testing, and we found these zones in shell plates, this region, and the other non-metallic inclusion zones were observed in heads of this pressure vessels, this region, and this region. This table shows the required measurements for level 1 and level 2 assessment. These measurements were determined by phase array ultrasonic inspection. In this case, it is required to measure parameters such as wall thickness, a way of lamination, circumferential and longitudinal dimension of lamination, minimum measured thickness, lamination height, lamination to lamination spacing, and spacing to a nearest major discontinuity, and spacing to nearest weld joint. Table 2, this table, shows level 1 assessment procedure of non-metallic inclusion zones that considered as a lamination if all criteria in this table be satisfied. The level 1 is accepted. However, in this study, level 1 assessment was rejected due to rejection of some criteria such as LMSD, LW, LH, and circumferential and longitudinal dimension of non-metallic inclusion zones, this criteria. So, level 2 assessment was required. In this study, because this parameter for lamination height was not satisfied, the non-metallic inclusion zones were assessed as a crack-like follow that used Part 9 of API standard for doing level 2 assessment. For this aim, the longitudinal and circumferential dimension of crack are equal to lamination height, and maximum value of circumferential and longitudinal dimensions of non-metallic inclusion zones respectively. And the ligament length is considered as the minimum measured thickness. So this table, table 3, shows level 2 assessment, and the level 2 assessment was done based on the results extracted from failure assessment diagram. We found that all non-metallic inclusion zones were acceptable and were in lower right corner of failure assessment diagram. Also, we observed that among measurement parameters mentioned in table 1, only the distance of non-metallic inclusion zones to weld metal or LW had significant effect on remaining life of each zone of non-metallic inclusion. In this case, decrease in LW or the proximity of defect ENV 3.2 decrease remaining strength factor as seen in this figure. According to this study, we introduced a new method for structural integrity assessment of pressure vessels containing non-metallic inclusion zones. In this case, we concluded that the most important dimensions for the assessment are lamination size and spacing to the nearest weld joint, or LW. If possible, it is advisable to skip the level 1 assessment and directly perform the level 2 assessment, since it provides a less conservative assessment when the non-metallic inclusion zones is evaluated as a crack-like defect. And this method can be valid in general, not for this study. Thank you for your attention.